Alright, so everybody can hear me, everybody can see the screen, right? One last test before we start. Yes, again?
Yes.
Alright, good. So we're starting back over now, guys. I know we did this before, if you were here before, but I'm starting back over. Because remember, I'm recording the session for persons who cannot attend. And this is the first question that we looked at, alright? So the question gave us this. It's called a binary operation. It's telling us that this means this. Or in another way, it could have been a star b equals the square root of a plus 4b. So it's a binary operation. It's an operation on two values. And the operations that we are familiar with are like plus, multiply, minus, divide, square root, square, stuff like that. We are familiar with those operations. What star is going to be a defined operation that combines these and maybe others. That's what it is. And in this example, they are telling us that star means that you take the first value, the value in front of the star is going to come on the square sign here. And the second value, the value after the star is going to come here after it is multiplied by 4. Alright, simple as that. So in this example, where they're asking us for 1 star 2, all it means is that the A in this case is equal to 1 and the B is equal to 2. Alright, and so basically I'm going to be setting this up just as how it is set up here. So this then becomes equal to square root. The first value is like the A coming in the first position here, where the A is 1 plus 4 times, and then the second value, the B, is coming here as a multiple of the 4. Alright, I'll come into multiply by the 4, so it's 4 times 2. Now this 4 times 2 is 8, 8 and 1 is 9, so we're actually doing the square root of 9, square root of 9 is 3. And so the answer for that part is 3. Alright, down here now, it's asking us to determine whether the operation denoted by star, which is called a binary operation, is commutative. Now the word commutative, I said commutative, is commutative. Commutative is the word that is used when an operation gives the same value if you switch the order of the operation. So for example, if we add 3 plus 5, it's going to be equal to 8. And if you switch around these two values and add them the other way, 5 plus 3, we're still going to get 8. And this is addition. And so we say the addition operation is commutative because when you reverse the order, the result is the same. Multiplication also is an operation that is commutative because if I multiply 3 times 5, I'm getting 15. If I reverse the order of this multiplication and do 5 times 3, I'm still getting 15. And so multiplication is commutative just as addition is commutative. So addition of real numbers and multiplication of real numbers is commutative. Now, what if we were to subtract these values instead? And I'm telling you now that subtraction is not commutative because if we do 3 minus 5, 3 minus 5 is going to be negative 2. But if we switch around the order and do 5 minus 3, then the answer is a positive 2. These two values are not the same. They are not equal. And because they are not equal, it means that subtraction is an operation that is not commutative because when you reverse the order of subtraction, the result is different. What if we were to divide these values and say, okay, let's do 3 instead of multiplying now, let's do 3 divided by 5, or let's do 5 divided by 3. Again, the result's not going to be the same because 3 divided by 5 is going to be 6 over 10, which is 0.6. But 5 divided by 3 is going to be 1.66 something. 666 repeated. Because it's going to be 1 2/3. Right? That's what this is going to do if you divide 3 by 5. And again, you're seeing that these values are not equal. Right? So when you reverse the order of division, the result is not the same. And so division is not commutative. So addition is commutative because when you reverse the order of addition, the result is the same. Multiplication is commutative because when you reverse the order of multiplication, the result is the same. Subtraction is not commutative, or you can say it is non-commutative, because when you reverse the order of subtraction, the result is not the same. Also, division is not commutative because when you reverse the order of division, the result is not the same. Those are the four main operations that we know about: addition, multiplication, subtraction, and division. Those are the four operations that we mainly know about, right? And we understand those operations. And we're applying now our knowledge of these operations to an operation here now that they are calling star, defined as this thing up here. All right? That's what it is. And we therefore now trying to find out if the star given as this definition up here is commutative or not. So a way to prove whether it is commutative or not, right, is to, for example, use an example. So if you use an example and when you reverse the order of the example, the result is not the same, it means that the operation is not commutative. You only need one example to prove that it is not commutative. And this question is kind of helping us and telling us an example that we can use, because it gave us 1 star 2 in the first part and the answer is 3. So a good way to test if the operation is commutative or not is to reverse this that we have already and see what the answer is. Now if I reverse these two and do it as 2 star 1 instead of 1 star 2 and work it out. Now when it is 2 star 1, all that happens now is that the a becomes 2 right here. So it's going to be equal to the square root, and the a is going to come right here, the first value, which is 2, plus 4 times, and the second value now becomes the b, coming right here. So we're going to place that value here beside the 4, multiplying with the 4. And then we work this out. This becomes 4 plus 2 is 6. So now we're doing the square root of 6. But remember, up here was the square root of 9, Now it's the square root of 6. Those two values are not the same. And so it means then that this 2 star 1 is not equal to 1 star 2, because 2 star 1 is root 6, while 1 star 1 star 2 is root 9 or 3. So because when you reverse the order of this operation, the result is not equal, it means that this star operation is non-commutative. And so we can draw the conclusion and say, therefore, star is not commutative. And there are some other properties of operations that we are going to have to deal with. One of them is called associative, the associative property. Another one is called the distributive property of operations. And I'll explain those at some other time. Just that the class today is not really about this, but because a part of the question was decided to give it to you. Now what it is that there are some topics that are not going to be taught, like, like PowerPoint presentation and notes and all of that. There are some topics that are going to be taught by example. And this is one of those topics that we're going to be doing by example, because you only really need to see one example done. Because in this example, for example, if I were to just change the values on this of this one and put instead, for example, say 4 star 7, all that would happen is that this will become equal to the first value is coming here just the same, which will be a 4, plus 4 times, and then the 7 is coming here, right? And that would work out to 4 plus 28, because 4 times 7 is 28, which would then work out to the square root of 32. So, questions like these, we don't really need to be teaching them like a topic and giving a lot of notes and all of that. We can just do them by example, and there are going to be some topics start like that. So when I'm doing past papers, I'm giving us practice, and I come up on a question that is going to be taught by example, we can just do it then, right? Come up on it again, because these don't come very often. They don't come on every exam paper. What we do as with notes and as topics and stuff are the things that come often, come on almost every exam paper. things that don't come very often and are easy to learn, and we can just learn them by example, we'll do them by example. Alright, and that's why I would have given you this question to do today. Alright, everybody good so far? Everybody good with this? Everybody okay with this? Let me take this out, not a part of the question. Everybody okay? To answer, you know, guys, especially because the internet not stable, you know, you need to let me know that you're there and you're hearing me and everything, okay?
Yes, sir.
Alright. Alright, let's continue. Alright, so this is a question I really wanted to do. Alright, this is a topic that we're doing in class now. Alright, this is a simple linear inequality to solve. Alright, and solve in mathematics means that you must make the unknown the subject. You want to find what value of x or what range of values of x would satisfy this equation or this inequality. You do that by making x a subject, and so it will be the same steps, the same process, really, if we were solving an equation with the same values, 3 minus 2x, or making that equation equal 5. It's the same steps to solve those two. The difference really is that with this one, because it is an inequality, if there comes a point in solving it where you have to multiply or divide with a negative number, multiply or divide with a negative number, you have to remember to reverse this inequality sign. That's the only thing really in terms of the steps. And sometimes what I like to do is just work both of them side by side to show you. Remember, don't have to do this, I'm just doing it just to show that it will be the same steps essentially to solve this one as this one. But just remember that for this one, if you have to multiply or divide with a negative number, the inequality sign must be reversed. Now, if we are solving this, we basically want to transpose everything away from the x. So we need to move this 3 and we need to move this negative 2. Order of operations suggests that we move this 3 first by bringing it over subtract. Right? So theoretically, what you're doing, you're subtracting 3 from both sides. And the same thing you have to do with this one. Subtract 3 from both sides. Alright? Let me separate the page. So if I'm doing subtracting 3 from this one, I'm going to be left with negative 2x equals, and then 5 minus 3 is 2. So you must say, take the 3 over here, carry it over, become minus 3. 5 minus 3 is 2. Alright? But theoretically, you're subtracting 3 from both sides. If I subtract 3 from both sides of this one, I'm going to get the minus 2x just the same. Sign stays the same because I did not multiply or divide, I only subtract. If I subtract 3 from this side, I'm still going to get 2 as well. So these two look alike, right? With inequality sign. The next step would have to be to get rid of this negative 2. And because this negative 2 is multiplying by the x, I want to leave x as a subject. We would have now divided this side by negative 2 and divide this side by negative 2 as well. Same thing over here. If I want to make this x a subject, to move this negative 2, I have to divide by negative 2 to cancel it away, and then divide this side by negative 2 as well. The shortcut is to say we take this negative 2 that is multiplying, bring it under this side and divide with it, negative 2. That's a shortcut. In any case, theoretically what we are doing, we are dividing by negative 2, both of them. For this one, we'll divide by negative 2 straight, no problem. It's an equation. Divide this side by negative 2, it becomes x equals, divide this side by negative 2. 2 divided by negative 2 is negative 1. This will be the solution if we were solving that. For this one, however, when we go and divide by that, by that negative 2, your brain have to remember, because there's nothing on the exam paper to help you now. You have to remember this in your head. There's no guide, no hint, nothing. Just your own brain. You have to remember that because it is an inequality, and dividing with a negative number, you have to go now and reverse that greater than sign. The inequality signs are greater than signs. So you have to reverse it. Absolutely have to remember this, otherwise you're going to get this question wrong. Right? So we divide this side by the negative 2, it becomes x. As I said, the sign has to be reversed to a less than, and then divide this by negative 2, it becomes negative 1. So you see they look alike. Just that we have to remember for the inequality, reverse the inequality sign. So this will be the answer for this question over here that was given up here. Right, that will be the answer. But I go with that? But okay with that?
Yes, sir.
Alright. Down here now, question wants us to draw a number line. Right? I want us to draw a number line to represent this solution. Alright? So let's look at it. So solution is that x is less than -1. Now this -1 is called a critical value or the boundary value. It's the limit of the inequality. Alright? So there's a -1 here. So it means that we're starting there. To show that we're starting there, we'll put a circle on it. But that circle on it is deliberately left unshaded because there is no equal on the inequality sign. The unshaded circle here is telling us that -1 is not included, because in this inequality, if you are only less than -1, it means that -1 is not included in your values. To show that -1 is not included, you put the circle on the -1 unshaded. If this inequality sign, for example, is less than or equal to, like that, then to show the equal to and to show that the -1 is also a value that is accepted, we would have to now shade the circle like that. That's what we would have to do to show that the -1 is included. But it was not included this time, so we'll take it off this and we'll leave the circle unshaded. Then because we want less than -1, it means that we want values on this side of -1 to the left. And so we'll put our arrow pointing to the left. And essentially then, this is your inequality, x is less than -1. That's a number line for that inequality. So this is the answer for this inequality. Alright, but go to that.
Hold on, sir. Quick question. So, for example, if it had the 3 minus 2x equals to 5, would that mean that you wouldn't shade the box?
Did that what? 3 minus 2x
2x
equal to,
equal to 5.
it's an
Would
equation.
you?
That's an
Oh,
equation. X is just equal to -2. That's a specific value. That's not a
oh,
range of. You don't put it. You
but,
don't put this. That will just be a specific value. If you want to represent this on a number line, you to just basically put the -1, put a circle and shade it. No arrow anywhere. That's it. If you want to represent that on a number line.
oh, so you wouldn't shade it if it was a range of values, sir.
No, it equal. Equal means now that you want the value, so you would shade the circle on the -1. If you wanted to represent this value on a number line, that will be it on the -1.
Oh, alright, sir.
They don't generally ask you for number lines for equations and values like that. They tend to ask for number lines for inequalities like these. Get me? They tend to ask for number lines for inequalities, not for values like this. They won't ask you to put that on a number line. Alright?
Yes,
Alright, good. This was all the question I told you to do. I told you to do all of this, right? Did I tell you to do this part as well? I said all of the number 2. Let me see what I said. Let me see what I said. I don't remember what you said. Did I want to do that part as well? Let me see. I said all of number 2, you know. Where is it? Let's see what I said. Yeah, I said number 2. Alright, so all of number 2. So let's do this part as well. Alright, so this question says, I remember, you know, reason why it will be good to do this question because we're doing linear programming, where you have to read certain statements and write the inequality for them. Now, these might not be inequality, but you still have to be able to read sentences and write equations, and also read sentences and write inequalities. This one says 2 adult tickets and three children tickets cost $43. Then it says 1 adult ticket and 1 ticket for a child costs $18.50. It says let X represent the cost of an adult ticket, so that's an adult ticket, and Y represent the cost of a child ticket, that's a child ticket. So 3 of them here, 2 of them there, add them up, it equals this amount of money, $43. Simple as that. You only use 1 adult ticket, which is X, and plus 1 child ticket, which is Y. Add them up, you get this amount of money, $18.50, which is 18.5. That's your 2 equations right now. You can fast. It's like that. Writing a statement in equation form. Let X represent the cost of an adult ticket and y represent the cost of a child ticket. Write two equations. See them here? These are the two equations. I can even just copy these down right now. These are your two equations that I want. Just like that. Two adult tickets, and three child ticket, three children tickets is $43. One adult ticket, and one ticket for a child, one child ticket cost is $18.50, 18.5. If you want to put 0.50, be my guess. If you want to put 0.00, be my guess. These values out here are immaterial after the decimal point. Alright, what they want to do is to solve the equation to determine the cost of an adult ticket. An adult ticket is X. So they want X. So since I want X, we really need to just be eliminating the Y. So to eliminate the Y from these two equations, let's write them back down here. Solving them simultaneously. There are multiple ways to do this. We want to use an elimination method. So it's 2x plus 3y equals 43. Since I want to eliminate the y, I'm going to multiply this one by 3. So let's call this equation 1 and call this equation 2. That goes better. Equation 1 and equation 2. So I'm writing back equation 1 as is, right? So equation 1 comes back as is right here. Then now, so let's put equation 1 here. Then equation 2 now I'm going to multiply it by 3. So I'm going to do equation 2 times 3. So I multiply equation 2 by 3. This and this becomes 3x and 3y. So I get 3x plus 3y equals, I need to multiply this by 3 as well. What did I get when I multiply that by 3? Let's see. Multiply that by 3, 18.5. I'm doing it on my calculator here. Times 3, 55.5. 55.5. Alright, those are my two equations that I have now. What I can subtract them. Subtract. I'm just going to subtract them. And I'm subtracting it this way. Right? Subtracting it this way. So I'm using the second one minus the first one. Why am I doing that? Because 3x minus 2x is just 1x or x. 3y minus 3y that gone equals 55.5 minus 43. Alright, what do I get for that? Minus 43.
13. No.
12. 12.5. 12.5. It's $12.50. 12.5. And they said I want the cost of an adult ticket. This 12.5 is $12.50. Therefore, adult ticket is $12.50. That's it. Alright. So that's the question I gave you. First question I gave you. Everybody good at that? But okay?
Yes.
Alright. So the next paper I gave it to do was 2019 question 4. Should be a summary right here. Alright, number 4. I thought that questions about training. It can be a very short session, but we can make it a quality session. Really learn some stuff, right? Number 4. Alright, this 4. Let me see. 4B. 4B right here. Alright. So I want to show you how you deal with inequalities that looks like this. Alright. So it says, given that, solve the inequality. When you solve an inequality like this, you leave x alone inside the middle there. And you have a value over here and a value over here. That's what you want. You want to transpose everything away from this x in the middle. That's how you solve this. So the first you want to do is get rid of this 5. Still an inequality. Still, if you multiply or divide with a negative number, these signs have to be reversed. Alright? So you're transposing everything away from this 3. So the first thing we're going to move is this 5. how do you move that 5? It is adding. You subtract 5. What you do, you subtract 5 from the 3 sides. You subtract it from the left, subtract it from the middle, and subtract it from the right. Alright, that's how you get it from inside here. You subtract 5 from the 3 sides. That's like this thing has 3 sides. So the left, the middle, and the right. You subtract 5 from this side, become negative 12. Negative 5, negative 7, and minus 5 more, even negative 12. Alright, so this side become negative 12. Less than, this stays as it is. When you subtract 5 from the middle, you're left with 3x. Then stays less than or equal to. When you subtract 5 from 7, you're left with 2. Then we need to get rid of this 3. How do we get rid of that 3? We're going to have to divide 3 on all the sides. Divide 3 by 3. And it's a positive 3. So these inequality signs, they stay as they are. I'll divide it with a positive number. Let me write it. Divide each side by 3 because I want to leave x alone in the middle. So when I divide this by 3, I'm getting negative 4. This stays as a less than. This becomes x. This stays as a less than or equal to. And this becomes 2/3 or 0.666. Let me write it as 2/3. 2/3. That's the solution. This is the answer right here. Simple as that. So they've been setting questions like this kind of inequality from time to time. But this is how you deal with it. Alright? Simple as that. Alright? Simple as that. That's how you deal with it. You could have also done it by separating it into two halves. So you could set up two inequalities out of this. So you could have had this half, which would be negative 7 less than 3x plus 5. And you solve this. And you solve this half as well, which would be 3x plus 5 less than or equal to 7. And you solve each part separately. Alright, but I've seen questions given where they actually give each part to solve as well. We're gonna see those questions some other time. But it's a nice, easy way to solve it. Alright, everybody good with that? Everybody okay? Everybody good with that?
Yes, sir.
Alright. Down here now, it wants us to represent this on a number line. Represent the solution on a number line. So this really means that an x value is between negative 4, not including negative 4 because there's no equal on that, and 2/3, including the 2/3 because there's an equal on this one. So we're going between negative 4 and 2/3. Okay, see? What happens is that the x is greater than the negative 4, but at the same time x is negative, less than or equal to negative, less than or equal to 2/3. Alright? So it gives us this number line that shows where the 0 is, but I didn't put any value on it. So let's put on some values for ourselves. So let's say this is negative 1, negative 2, negative 3, negative 4. We're going to put 1 right here. Alright, remember 1 is actually more than 2/3. So if we take this as an interval of 1 between 0 and 1, and you want 2/3, it's like you divide it the 3 equal parts right here. I'm focusing on now, like this. 1 part, 2 part, 3 parts. And right here with 2/3 of the part. So this value is 2/3 right here. Is 2/3. That would represent 2/3. Alright? Right there will represent 2/3. Then now, if I want to show the number line, let's look back at it. So I'm putting a circle on the negative 4 down here. And I'm leaving it unshaded. Why is it unshaded? Because there's no equal on the inequality sign. Then I'm going to put in a circle on the 2/3 right here. Put in a circle on the 2/3. And that circle is shaded because what? There's an equal on this inequality sign. So the 2/3 is an included value. So I'm shading this circle. And then to show that I want values between them, I can just join these. The arrow pointing to the right from this one, and the arrow pointing to the left from this one. Write inequality on it. X less than or equal to 2/3, but greater than negative 4. And that would be my number line for that inequality. Nice and easy like that. But okay with that? Very good. Any questions? Guys, you have to talk, you have to talk. And not in the class where I can see your facial expressions.
Yes, sir.
What I should do.
Yes, sir. Yes, sir.
Soon as silent means that everything good. Alright. So if you don't understand, you have to talk. Alright. If you don't understand, you absolutely have to talk. Alright, let's continue. Did I say all of 4? No, I said 4B. Right, I didn't want to do this part. I think we did this part already in a coordinate geometry question class, right? We did this part already actually in a coordinate geometry class. I really want us to focus on the inequalities. So that finishes what we're doing on this paper. The next paper I gave you was, let me see. I gave you 2021. Alright, so basically finish with this question. I wanted to show you this one. More maths equals better maths. Progress before perfection. One step at a time. Alright, 2021. And the 21 question is supposed to be 4B as well. Let's see what that one was. 4B. So it's a quick session that we're doing just to get some revision work and some practice work. Remember, if you didn't do the question, you need to go and do it. If you didn't get it right, you need to go and do it. Alright, question must be done. So we did 4A already, or the coordinate geometry. Hold on a second, guys. Right. 4B. This is the same stuff. 4B and 2021. Let me see. 2021. I said 4B. This is 4B. You know I do this now. This is 4B. If I gave you the wrong question. I don't want you to do that no, man. I would like to the 4B for that one. Let me see. I think I told you the wrong question, guys. Oh, it's January 2021. Oh, sorry, my mistake. January 2021. This one, okay. January 2021, not June. Okay. Looking for 4B. Just a gradually we're going to be exhausting all these questions. A little bit at a time. Alright, so this is a question where they gave us these equations. Right? So it's like a combination of coordinate geometry and inequalities and linear programming in a sense, right? Or linear inequalities. They tell us to use a ruler to draw these lines. X equals half, y equals x plus y equals 5. Easy lines. These are all easy lines to draw. X equals half is a vertical line passing through half. Is a x equals a number line. All you can remember is a vertical line because the y-axis, remember, is the line x equals 0. So x equals a number will be vertical like the y-axis. X equals half will be vertical like the y-axis passing through half. So here is 1. So this must be half right here. So the line that we want for x equals half is a vertical line down here. Vertical line down here. Alright, vertical line down here. Is the line x equals half. You have to use a rule and do it. Don't do it friendly like me. Alright, so down here will be half. And the line is x equals half. And you label the line x equals half. That's the first line. Second line is y equals x, an easy line to draw. Passes through points where the x and the y value is the same, like 0, 0, 1, 1, 5, 5. See, it says y equals x. So it passes through points where the x and the y value is the same. So when the scale on the graph is equal, it passes right down the middle. So it passes through 0, 0, pass through 1, 1, 2, 2, 3, 3, pass through 4, 4, all those points. That's not 4, 4. This is 4, 4. So you pass right down the middle of the graph. Use a ruler and draw that line right down the middle of the graph like that. Right? Draw it right through. And label the line with the equal sign. Always remember to label the line with the equal sign. Don't draw it friendly like me, guys. Use a ruler. Use your ruler and draw it, alright? This is the line y equals x. Then they need the line x plus y equals 5. Again, this is a very common and popular line. I call it the x plus y lines. Because the x plus y equals 5, it means that it crosses the y-axis at 5 and also crosses the x-axis at 5. That's the x plus y equals lines. Right? And it's easy to understand why that is so. Because remember, on the y-axis, the x value is 0. And so you have y equals 5. And on the x-axis, the y value is 0. And so you have x equals 5. So it passes 5 on the y-axis and 5 on the x-axis. It passes through points where the sum of x and y is 5. So it's going to pass through here. And also going to pass through here. So those 2 points go to use rule and draw a straight line through it. But I want to get it a bit accurate. So it's also going to pass through 1, 4 right here. Because 4 and 1 is 5. Going to pass through 2, 3 right here. Because 2 plus 3 is 5. Going to pass through 3, 2 right here. Because 3 and 2 is 5 again. Going to pass through 4, 1 right here. Because 4 and 1 is 5. So it pass through all those points where the sum of the x and the y value is 5. Alright, so it's a straight line down here we want. Straight line down here. Alright, they label the line with the equal sign. X plus y equals 5. So those are the 3 lines that I wanted us to draw. But good with that so far? But okay with that?
Yes, sir.
Alright, down here now, it says we are to label R region where x is greater than half, y is greater than x, and x plus y is less than 5. And since you have the line, you just need to know above which one, below this one, and which one, and so on, right? So this one is x greater than half, so this one is going to be above. See? Above. Greater than means above. Above the line, x equals half. That's what this inequality is. And it's a solid line. All the lines are solid. See? The equal is on all of them. So all the lines are solid as drawn. But we want above a vertical line x equals half. So it means that we want to the right of this vertical line. To the right of it. I'm putting an arrow just to tell us which side of the line we want. To the right. And this one now, the whatever here is positive. So it's greater than means above. So for this one, we're going above again. Above that line. And the line we're talking about is y equals x. That's the line associated with this inequality. So line y equals x is the second line. We want above it. So putting an arrow pointing up. Right? So we don't want under here now. Nothing under here is good. We have to be above this line. So if we were to narrow it down like we're inside this, we want so far. To the right of this and above this. But we're not shading anything yet. I'm just going step by step. Then this one now, this third one now. The y on the right side here is positive, so this less than means below. So here now we are going below. The line we're going below is x plus y equals 5. But this is the line associated with this inequality. It's already a solid line on the graph, right? Because the equal is there. So we're going below that line. This is the line x plus y equals 5. We're going below this one. Below this one. Let's put it all together now. We are above this one. Above this one. And below this one. So the region I want is in here. See? Above this one, above this one, and below this one. So R is supposed to be inside here, so that's where R is located. That is it. What go with that? See, R the wanted, not shade R. Nice easy question. What good? That triangle here is the shaded region, or the region that satisfies the three inequality called a common region. But they didn't want us to shade, they just wanted us to write an R in there. That is it. But cool with that?
Yes, sir.
Alright, good, beautiful. Alright, so that's number 3, right? 1, 2, 3. So the next one I gave you to do was 2014. But I think I'm under 2014 last. 2014 I can write on the paper itself. So let me see what the next one was after that. I'll give you 5. So I gave you May 2021, and you were to do number 8. Alright, so I think that was the actual linear programming question. May 2021, question 8. Question 8 on this paper. You're supposed to do. Let's see. Question 8. Alright, here we go. Let's look at this one. Remember guys, any question you didn't do, you need to go and do it. Any question you got wrong, you need to go and redo it. That's how we learn, that's how we improve, that's how we get better. Put pen and paper. Cannot just watch sir do it. That is not good enough. You have to absolutely do the questions. Right, you have to do the questions. Alright, this question says Marla buys 2 types of mobile phones, B Flow and C Flex. We're just gonna call them B and C for simplicity, right? The B phones and the C phones from a company for retail. So buy from a company because she wants to retail it. It says one B phone costs $60 while a C phone costs $80. It says she buy X number of B phones. So it's X B phones she buys, and she buy Y of the C phones. Let's make a note of it now. So we have information in front of us, right? I don't want to be seeing all these words when I'm ready to work. So I'm gonna put some information here. So she bought XB phones, and she bought YC phones. Just using B and C. The flex and the flow can stay. C phones. If I'm in the exam, I'm writing these notes on the paper just as I'm doing here now. The cost of the B phone is $60 each. Let me put it here as well. $60 each. So this one is $60 each. $60 for one. And the other one is $80 each. $80 for the C phones. $80 each. It says Marla must not spend more than 1,200. So the total money that she's spending cannot pass 1,200. It says write an inequality to represent this information. No, she can spend the full 1,200 or she can spend less. What is that amount of money that she's spending? She's actually spending $60 times X phones, because she's buying X phones at $60 each. So the money she's spending on the B phones is 60 times X. Plus, she's buying the C phones, Y of them. So, and she's spending $80 for the Y phones, for the C phones. So, the total money she's spending on the C phones is 80 times Y. So, overall, she's spending $60X for the B phones and $80 for the C phones. That's the total. So that total spent can't pass $1,200. So the inequality then becomes 60x, that's for the B phones, plus 80y, that's for the C phones. That's the total amount spent. Cannot pass this amount, 1,200. That is the inequality. And this can be simplified. That can be simplified. We can divide through by what? 20. Yeah, we can divide this by 20, this by 20, this by 20. So let's do that, right? We can divide off the zeros first. That's tens, and then we can divide through by 2, right? So we can divide through by 20. So let's do that and simplify. You must always simplify your expression. So we're going to divide through by 20. That will simplify the lowest terms. So we divide this by 20, it becomes 3x. Plus divide this by 20, becomes 4y. Less than or equal to divide this by 20, becomes what? 60. 60. Right, that is it. But go to that. But okay.
Yeah.
Alright, so that's the inequality right there, guys. That's the inequality. Alright, nice and easy. So working with this one, the simplified one. Next one says, the number of B phones must not be greater than or equal to the number of C phones. So remember, the number of B phones was X. Is X was the number of B phones? Yes. Must not be greater than, oh, must be, not. It says must be greater than, is greater than or equal to the number of C phones, which is Y. It says write down an inequality X and Y for this information. This is it. Let me just move it down. See there? The number of B phones must be greater than or equal to the number of C phones. X is the number of B phones, Y is the number of C phones. But guess what? What is it with inequalities? You don't like when Y is on the right side. We want the Y to be on the left side, and we want to do positive, because that is when less than means below, and that is when greater than means above. So I'm going to take this inequality and actually switch it around and write it instead. I'm going to say i.e. that is y is less than or equal to x. It is the same inequality. I've just spun it around, or I've read it from right to left. Because to say x is greater than or equal to y is the same as saying y is less than or equal to x. So I prefer to work with this one, because this now means below. We want below the line y equals x for this one. So I prefer to work with this. But if you write this, you get an answer same way, you know. But in terms of interpreting what we put on the graph, I prefer this one, because this less than sign means that I want below the line. If we work with this greater than sign, you might make a mistake and go above the line, which is not right. Alright, let's continue. Then it says, represent the two inequalities on this graph, on the grid below, and label as R the region that satisfies two inequalities. Alright, I think there was an issue with this question. That's what it was. Oh, I remember now. The scale. There's an issue with the scale. Look here. It is 1, 2, 3, 4 intervals to 5. Same thing here. 1, 2, 3, 4 intervals to 5. But then up here, the last one up here, between 15 and 20, it is 1, 2, 3, 4, 5 intervals for 5. So they actually made a mistake with the scaling of this graph. What did Mr. Shaw do in this exam? Mr. Shaw would rescale it. That's what Mr. Shaw would do. I will rescale it, because the scale here is different from the rest of it. It's 5 units to 5 right there. I can say 1 to 1. But down here is 4 intervals equal 5. So the scale is incorrect. And they do make these mistakes on exam paper from time to time. Don't be surprised, because remember, it's human beings market setting these papers, and so they can make errors as well. And this was an error that was made on this paper. Now, if I'm going to draw this graph, can do one of two things. I can change this to 4, 8, 12, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. Put 16 right here, so see this 20 will be wrong. Right? But then, if I do that, I might have a problem drawing this graph. Not necessarily, but let me show. Right, let me deal with let me deal with the points that I need for this graph first, and then we decide on what scale we use down here. Alright? What scale we use. Let me do what these inequalities mean. What do I need to represent on a graph? Let's do this one first. In terms of how to represent this on a graph, and what I'm writing in red is not necessary to draw the graph, but generally speaking, to draw this graph, we want 2 points. Right? Now the y over here is positive, so this less than means below. Means that we want to go below this line. The equals are part of the equal, so we're drawing an unbroken solid line. So we're going to draw a solid line. And the line that we're drawing is associated with this inequality, which is 3x plus 4y equals 60. So what a quick way to draw this line. I keep doing it. You have to practice it. We can put on 2 points. One of them, we give it an x value of 0. The other one, we give it a y value of 0. For the one where the x value is 0, it's like you put the 0 right here and this is all gone. You'll be left with 4y equals 60. If 4y equals 60 divided by the 4, 6 divided by 4 is 15. It means that 0, 15 is a point on this line. For other point where the y is 0, like I'll take the y and plug for the y here, the 0, and plug for the y here, this is all be gone. You're going to be left with 3x equals 60. If 3x equals 60, it means that x is 20 at that point. So 6 divided by 3 is 20, so that's 20, 0. So you see, it means that these 2 points are on the line. So I would want to see 20, 0. I'm not going to complicate it. I want to see where 20 is on this graph. And this is the wrong 20. This 20 is not correct. Alright, so what did Mr. Shaw do in the exam? Mr. Shaw, in the exam room, would do a thing like this and just change the scale. Mr. Shaw would use his pen and mark out some of these things. I would mark these out. I'm not using their scale. I'm going to create a different scale because their scale is incorrect. I'm marking these out, but this 20 is not correct. Right? Because this 20 and the 20 up here is not the same 20. Right? Keeping it simple for myself. I'm going to use that 20, but then you see we might have a problem finding the point of intersection that I needed. You see if I want anything from the graph. It says the total number of mobile phones represented by x and y. It says according to the graph picture, what is the largest possible value of x and y? We can use the scale now, but this 20 up here would be right if you're using the scale that they gave us. This 20 would be right. If you're using the same scale that they gave us, then that 20 would not be right. Let me try to work with this scale and see what happens. Let me try, but this 20 up here would not be correct for sure, right? Because they're going 4 lines to 5, 4 lines to 5, 4 lines to 5, 4 lines to 5, and then all of a sudden up here they go 4 lines. So up here, this 5, this 20 really is supposed to not be here, but here. That is where that 20 is supposed to be. Alright? That's where that 20. And then now, the question is, what would each of these mean? Each of these would basically be 5 divided by 4, because this is an interval of 5, and there are 4 of these spaces there. So each of these would be 5 over 4, which is 1.25. So it's like this would be 1.25, and then 1.25, this would be 2.5, which is correct, halfway between 0 and 5, and then this would be 3.75. 3.75, this one. Alright, so each of these intervals will be 1.25 if you want to work with that. But if you're using this scale, guys, this is what you're gonna have now. Let's draw it. Let's draw it in blue. Let's use a scale and draw it. But I made a correction at the top. Right, obvious that this would be 20. This would have to be 20, right? So, if you put it on the graph, the lines, first one up here, using 0, 15, and 20, 0, right? 0, 15, and 20, 0 for the first line. So 0, 15 will be right here, and 20, 0 will be right here. So you have to use a ruler and draw a straight line through them like that. Bam. Alright? That is it. Then now, other line down here, and one below this line, right? Below this line. This one kind of easy. Y equals x. So y equals x passes right at the middle of the graph. As usual, it passes through 0, 0. It's going to pass through, for example, 10, 10. Right here. 10, 10. 10, 10. Right? And pass through 5, 5 right here. Right? So this line will go like this. Right on the middle of the graph, like this. Alright, so this one down here, we never label it, is x plus y. No, not x plus y, it's 3x plus 4y. This one will be, what did I do? Yeah, 0, 15, and that, right? So this one is 3x plus 4y equals 60, right? First one, label line with the equal sign. 3x plus 4y equals 60. That's this line right here. And we're going below that line. The arrow pointing down on it. Below this line. And we're going below this one as well. Right? And below this one as well. So this is the line y equals x. And we're going below this one. So if you want below both lines, it means that you really want this triangle in here. Here's some. Alright, you want that triangle inside here. And then, what else do we know? On that triangle, what did they tell us to do? Label it with anything. So leave it R, right? Leave it R. So R is down under here, below both lines. So this is a R and put it anyway. Big R inside here. So that's the region below both lines. That will be a region below both lines, alright? Alright, that finishes this part. Then now, it says down here, it says the total number of phones is represented by x plus y. It says according to the graph, what is the largest possible value of x plus y? Largest possible value of x plus y. Let's call that value. So value is x plus y. The largest value of x plus y is at one of the vertices, just the same. Whatever value, whatever it is, the number of phones, total number of phones is x plus y. Right? You have to go to one of the vertices and see what those values are. What are the vertices of the region? This is the region that we want to know. Where are the vertices? The vertices are here, here, and here. Now this vertex clearly is 20. It's 20, 0. So this vertex is 20, 0 right here. 20, 0. So total phones here says 20. Right here says 0, 0. That's no phone at all. Right? It's either this one or this one. So we need to know what this one is. So the question is now, what are the coordinates right here? Let's see if we can work with the coordinates right here. Let's work with the coordinates right here. Alright. So alright, it kinda easy, you know. Let me tell you why it's easy. Because right here, so the total is 20, right? Total is 20. Now you see at this point, x and the y value is the same, you know. Because on the line y equals x. Now this point is 10, 10. This point is 10, 10, you know. Right here, so it's 10, 10. And put it in blue. This point here says 10, 10. This point will add up to 20. So this point is less than 10. Less than 10. So this point has to be total less than 20 right here. Has to be. I don't have to work out anything. This point has to be less than 20 phones total. Because remember the x and the y equal at this point, because it's on the line where y equals x. I don't have to get into the value. But see, if this point is 10, 10, then this point clearly is less than 10. Less than 10. So this point, x plus y is actually less than 20 right here. So x plus y is less than 20. For sure. But x plus y equals 20 down here. So this is the point down here, so where x plus y is maximum. 20, 0. So the answer for this is the point 20, 0. So the total number of phones represented by, according to the graph, what is the largest possible? 20, 0. Alright? V max, let's call it value. V max. V max, we call it in the formula value. V max. V max is equal to 20 at the point 20, 0. That's the answer. That's the maximum value of x plus y. Maximum value of this x plus y. That is it, guys. Understand that? Understand that reasoning? That this point can't reach 20. Because 10 and 10 is here. At this point, x and y value is the same, but both of them less than 10, 10. So the total at this point can't be 20. So this total of 20 here is greater than that here. Make sense, everybody?
Yes, sir.
First thing, remember your maximum and minimum must occur at a vertex. So if you're looking for the highest value of x plus y, you go to the vertices. X plus y down at this point on the x-axis is clearly 20. 20 plus 0 is 20. This point out of it, right? Because that is 0, 0. So the next point we have to look at is this one. But this point can't reach 20. Why is that? Because the x and the y value at this point is the same, and each of them less than 10. Oh no, each of them less than 10, because this is the point 10, 10 right here. So this point, the x and the y value both less than 10. See here? This is the y value which is less than 10. This is the x value which is less than 10. So the x and the y value both less than 10, then the sum of x plus y must be less than 20. So the total down here is greater than the total up here. So the maximum of x plus y is at this point, 20, 0. And that is why the maximum value is just 20 at the point 20, 0. Done. Alright? That is it. Easy question. There's one mark for it now. So it's easy for true. Alright, that finishes that. And the next paper I gave was 2014. Let me go to 2014. Give you a question on 2014. So one good thing about that graph a while ago, the 20 at the top was not needed. So maybe that's why we could work with it. The scale. But the 20 at the top was not needed. Because the point where across the y-axis was 0, 15. That's the only good thing about it. Alright, so there's a question on this now that I'm gonna have to bring up another. Is which question I told you to do on it? Let me see. I think it's this one, number 2. I think it's just this one. Let me see. Let me see what I told you to do on this paper. Told you to do 2 and 4. That's the number 2 there. And also told it to the number 4. Let me see what number 4 is. Okay, good. Alright, 2 and 4. Let's bring up something else and work. Alright. Let's stand 2. First part is first to solve this. First part is first to solve this thing. Same thing, make x a subject. It's an inequality. So all we have to do is transpose away everything, make x a subject. We have x term here and x term here. So let's work it out. So we have 2 into x minus 6 plus 3x less than or equal to 8. Alright? There's nothing to it. Just like solving this with an equal sign. Only difference with the inequality is if I have to multiply divide with a negative number, you're going to have to reverse this inequality sign. Open this bracket first. I'm going to get 2x minus 12, or the 2 times this 6 is 12, plus back this 3x less than or equal to 8. This 2x and this 3x is 5x less than or equal to 8, and this negative 12 goes over here and becomes a positive 12 plus 12. So it's 5x less than or equal to 20. 12 and 8 is 20. They divide both sides by 5. That's a positive number we're dividing by. So you divide by 5, we get x less than or equal to 4. And that's the answer. Alright, it says, show, using a number line, show the solution of this. So it's less than or equal to 4. So we're going to go 0, 1, 2, 3, 4, 5, negative 1. Critical value is 4. You put a circle on 4. E equals a part of inequality, so you shade it. Show that negative 4 is included. And then less than 4, you mean you want the arrow pointing to the left. And that's it. X less than or equal to 4. That's a number line. Nice and easy. Alright. This one wants us to factorize these things. Let's just practice it. Factorize this one. So we have 3x minus 6y plus ax minus 2ay. 4 terms that are factorization by grouping. If you factorize these two, you come and factor by 3, you're going to have x followed by y. Look over here, you have x followed by y as well. So there's no need to rearrange the values. You just proceed. Highest common factor in the first 2 terms there is 3. So you factorize the 3 out of this, you're going to get x minus factorize 3 out of this, we're going to get 2y. I'm going to try x minus 2y in the bracket over here as well. And then now from this ax, if I factor in the x, you must have factored out the plus a. Alright, so you factor out a plus a. If you're not sure, you can check back this expansion. A times x is ax. A times minus 2y is minus 2ay. So you know, say good. Then now this becomes your common factor, and they are connected with 3 plus a. So this then becomes equal to 3 plus a connecting x minus 2y. Basically that is it. Alright, that's this one. And this one, that's just the difference of 2 squares. Because you have p squared minus 1. This one is the same as 1 squared. So it's p squared minus 1 squared. Difference of 2 squares. So it becomes p minus 1 times p plus 1. Done. That is it. P minus 1 times p plus 1. Alright, we'll move on. Part C wants us to expand this. Let's go. So we have 2k minus 3 times k minus 2. Alright, so expansion basically goes like this. This times this, and that times that, and this times this, and that times that. Or you can say, use this 2k, multiply each of these first. You're going to use a minus 3 and multiply each of them as well. Alright, so we're going using the 2k first. 2k times this and then 2k times that. I'm going to get 2k squared minus 4k. Alright, what did I get that? 2k times k is 2k squared. And then 2k times minus 2 is minus 4k. time to use is negative 3. So negative 3 times the k first is minus 3k. Negative 3 times negative 2 is positive 6. So care for those negative signs. It's positive 6. So consolidate these in the middle. Minus 4k and minus 3k is minus 7k. So it becomes 2k squared minus 7k plus 6. And that's it. Done. Next part says the line whose equations are this and this. They intersect at xy. It says show that the point of intersection is 1, negative 1. We can do this by solving these two simultaneously and getting the answers. But a way to do it as well, you can show that these values satisfy this equation and satisfy that equation. If it satisfies both of them, then it is a point of intersection of both of them. So you don't really have to solve them, You don't have to absolutely have to solve them, but you can solve them still. Right? I'm going to show you both ways. So let's say we're using a solving method, right, for these two equations, and the answer is supposed to be this. So we have 3x plus y equals 2, and we have 4x minus 2y equals 6 if I'm using an elimination method. So this one is the first equation up here, and this is the second one down here. And the thing about this one, this one can be divided through by a 2. This one can be divided through by a 2, as these are all multiples of 2. So this equation stays as it is, not changing anything on it. 3x plus y equals 2. For this one, I'm going to simplify it and divide by 2. Divide by 2. This becomes 2x. This becomes minus y. This becomes 3. Then I add the two equations. I might add in them because when I add this plus and minus y, they eliminate each other. So 3x and 2x is 5x. These are eliminated, and that is equal to 2 plus 3 is 5. We divide both sides by 5 now, or we take this 5 and divide it under here, then we get the x equals 1. Then when you get the x equals 1, you can plug that 1 into this equation up here, or you can plug it into this one. Let's plug it in the first one. So we can just say, and take the 1 and put it here. We're going to get 3 times 1 plus this y equals this 2. This is 3 now. 3 goes over and subtract. We get y equals 2 minus 3, y equals negative 1. And therefore the point of intersection has this x value of 1 and this y value of negative 1, is what they said it was, which is true, and therefore shown. Alright, I'm now bother with the other method. Alright, I'll show you the other method some other time. But other method, let me show you the other method. Let me just show you. So the other method, because it actually give you the point, is a matter of plugging these values in the two equations and show that they satisfy the equation. So for example, we have the 3x plus y equals 2. Test the point 1, negative 1 in there. How you do that? We're going to substitute the x right here with 1 and substitute the minus 1 right there. When you do that substitution, you will get 3 times 1 plus a negative 1, and then this is 3 minus 1, which is equal to 2, which is true. So it means that that point is on that line. We're going to try for the other line now, which is 4x minus 2y equals 6. You want to see if this point is in it as well. So you do that. You take the 1 and we're going to put it in there so for the x, and negative 1 and put it in there so for the y. See if it works out to be 6, which it will. So it's going to become 4 times 1 minus 2 times negative 1. Now this is actually 4 plus 2, it's minus 2 times minus 1 is 2, and it's add up to 6. 6. Again, this is true. So because the point 1, -1 satisfies, meaning it works on both equations, it must be the point of intersection of two equations. Because two lines can only intersect at one point unless it is the same line. And then in that case, it will have an infinite number of points of intersection. But two non-parallel lines can only intersect at one point. Alright, guys. Alright, so that finishes that question. And number 4 now. Number 4. This question. And we can mark of it on the screen. Number 4 right here. So number 4 says the diagram below shows a graph of 3 straight lines. Y equals 2, y equals x, y equals x plus 2. Question says state the correct equation for each of the lines. So line 1. So line 1 has to be this one. Why is that? I see it has a y-axis intercept of 2 right here. And the gradient is 1. Oh no, the gradient is 1 because this is 1x. And the gradient from this point to this point will have a run of 2 and a rise of 2. 2 over 2, which is equal to 1. Alright? So line 1 is this one. Alright? Y equals x plus 2. Y equals x plus 2. Then line 2 is the line y equals x, this one. See, pass through the origin and pass through the point 2, 2 right here. 2, 2. Right? So that's line y equals x. So line 2 is the line y equals x. And then line 3 is a horizontal line. It should always have an equation y equals some number. That number is 2 because it passes the y-axis at 2. So that's it, y equals 2. So the third line is y equals 2. Y equals 2 is the third line. Alright, next part now says show that the gradient of line 2 is 1. Show the gradient of line 2 is 1. So line 2, that's this one. Show it is 1. We can say it pass through 0, 0 and 2, 2. So we can say it pass through 0, 0 and it pass through 2, 2. So therefore the gradient is a rise of 2 and a run of 2 over 2, which is equal to 1. We could do that.
Sir, could you also just use 2 points on the graph?
Huh?
Could you also just use 2 points on the graph or no?
Yeah, that's this one and this one. Those are 2 points that you know for sure. 0, 0 as I have here, and 2, 2. Right? So it will be 2 minus 0 over 2 minus 0. This y value minus this y value divided by this x value minus this x value. I could look at the graph and say that from here to here, the rise is 2 and the run is 2. So rise 2, run 2. 2 over 2 is 1. Maybe you want to look at it. Alright, that is it. So the gradient is 1. Next part now says shade the region for y greater than x plus 2. So this means above. Y is positive, it means that we want to go above. This means above the line y equals x plus 2. That's what this means. Above y equals x plus 2. So this wants us to shade above y equals x plus 2. So which line was y equals x plus 2 again? The first one you saw. So we're shading up here above it. That's what I want, above this line. That's it, above that line. Alright, up there is y greater than or equal to x plus 2. Next one says, write three inequalities to define the shaded region S. Write three inequalities for S inside here. Alright, let's look at it. So look at it. Let me take these out. Now this shaded region, first it is below line 3. Line 3 was y equals 2. So the shaded region is y less than or equal to 2. Why am I putting the equal? Because they have solid lines. That's the first one. Then now, this line is actually x equals 0. So y-axis is actually x equals 0. And shaded region is to the right of it. So in terms of this one, it is x greater than or equal to 0. Right? And then this line now is y equals x. Y equals x, and it's above y equals x. Y equals x. So the equality related to this line is above is y greater than or equal to x. So these are your three inequalities. This one, and this one for the shaded region. So the key one to know, guys, is this one. This line is x equals 0, and shaded region is to the right of it. And to the right of x equals 0 is x greater than or equal to 0. So those are the three inequalities I've circled in blue. But see that? But you understand that?
Yes.
Alright. It's a nice question to redo and a nice question to redo. This one says, write the equation of a straight line which is perpendicular to line 1 and passes through the origin. Alright. Line 1. Which line is line 1 again? Line 1 is this one. So the question is asking us for, let me draw that line in purple. The line that is perpendicular to line 1, right, and passes through the origin, so it goes like this. Goes like this. This line 1. Perpendicular to line 1. Now, the gradient of this line is minus 1 over the gradient of line 1. Gradient of line 1 is 1. Remember, line 1 is this line, you know. This is line 1, you know. This line 1 was y equals x plus 2. Gradient of line 1 is 1. So the gradient of this purple line is negative 1. Negative 1 over 1 is negative 1. And the part, not 1, negative 1. Take these off. And it passes through the origin. And so the c equals 0. So the line is therefore y equals minus x. Remember, we're using y equals mx plus c. C is 0. So that's gone. So it's just y equals mx. And the m on this line is negative 1. So it's negative 1x or just negative x. That's the answer right there for this part. Y equals minus 1x. Or you can just put minus x. Done. The three inequalities for this part down here is x greater than or equal to 0. As it is to the right of the line, x equals 0. It's below y equals 2, so it's y less than or equal to 2. And it's above the line y equals x. And so it is y greater than or equal to x. That's three inequalities for this part right here. That is it, guys, for today. Remember, you have to go and redo the questions. Alright? When I redo the questions, and nobody no foolishness. When I redo the questions. Alright? So next class is Saturday online. Saturday online, we'll do some more practice work. I know I want to come back face to face on Sunday. Let's hope everything.
Your third class done?
Huh? Yeah, we're done now. We're done. Yeah. That's all the questions I gave it to do.
Yes, sir.
I'm gonna send some more questions for you tomorrow. Keep practicing. Maybe Saturday we'll do some general revision, some quadratics and functions and coordinate geometry. Just do a revision, a general revision on Saturday. And come back Sunday to finish out the linear programming. And maybe some more linear programming. I'll decide what we're doing tomorrow. But that is it for today, guys. Keep practicing. Keep practicing. Keep practicing. Alright, more maths equals better maths every time. Can't go wrong with more maths. Can't go wrong. Alright. See you. So your homework tonight is to redo the questions you didn't get right. Or do the questions you did not do. I'm gonna send the video to the class right away as soon as we're done. So see you in class, guys. Bye, buddy. Good night.